Hello everyone, this is Mrs. N. Arulsmati, Assistant Professor from CSE Department, Rogini College of Engineering and Technology. In this session, we are going to discuss about 16-bit microprocessor, 8086 microprocessor features and architecture under the Unit 2 8086 microprocessor architecture and programming. 16-bit microprocessor features and architecture. 8086 microprocessor is a 16-bit microprocessor. 8086 has 20-bit address bus can access up to 2 power 20 memory locations. It can support up to 64K input-output ports. It provides 14 16-bit registers. Word size is 16 bits and double word size is 4 bytes. It has multiplexed address and data bus AD0 to AD15 and A16 to A19. It requires single phase clock with 33% duty cycle to provide internal timing. 8086 is designed to operate in two modes. They are minimum and maximum. It can prefetches up to 6 instruction bytes from memory and queues them in order to speed up instruction execution. It requires plus 5-volt power supply, a 40-pin dual inline package. Address ranges from 000H to FFFFH. Memory is byte addressable. Every byte has a separate internal architecture of 8086. 8086 has two blocks, BIU bus interface unit and EU execution unit. The BIU handles all transactions of data and addresses on the buses for EU. The BIU performs all bus operations such as instruction fetching, reading and writing operands for memory and calculating the addresses of the memory operands. The instruction bytes are transferred to the instruction queue. EU execute instructions from the instruction system byte queue. Both units operate asynchronously to give the 8086 an overlapping instruction fetch and execution mechanism which is called as pipelining. This results in efficient use of the system bus and system performance. BIU contains instruction queue, segment registers, instruction pointer and address adder. EU contains control circuitry, instruction decoder, ALU, pointer and index register, flag register. This is the diagram of 8086 internal block diagram. Here we can see ALU, arithmetic logical unit, and we can see the control system and registers, B bus interface unit, it contains the segment registers, and EU unit, it contains the accumulator registers, AHAL, then BHBL registers, CHCL, DHDL registers, stack pointer, base pointer, stack index, source index register, destination index register, bus interface unit. The bus interface unit handles all data, address and control signal transfers between the microprocessor and external devices. Functions: fetches instructions from memory, calculates physical addresses using segment and offset, queues instructions for the execution unit. Components: segment registers, CS code segment stores code segment address, DS data segment stores data segment address, SS stack segment stack operations, ES extra segment additional data storage, instruction pointer IP holds offset of the next instruction, instruction queue 6 byte FIFQ for prefetching instructions. Execution unit. The execution unit execute instructions fetched by the BIU. Functions: decodes and executes instructions, controls ALU operations, Manages flag registers. Components. Arithmetic logic unit performs arithmetic and logical operations. General purpose registers AX, BX, CX, DX. Each register can be split into high and low bytes. Pointers and index registers. Stack pointer, base pointer, source index register and destination index registers. Flag register holds status flags, that is zero flag, carry flag, sign flag, overflow flag. Control unit directs operation flow. General purpose registers AX. Purpose of AX register is to word multiply, word divide, word input output. AL byte multiply, byte divide, byte IO, decimal arithmetic. AH register byte multiply and byte divide. BX register stores address information. CX register it is used for string operations and loops. CL register variable shift and rotate. DX registers word multiply, word divide and indirect IO. Pointers and index registers used to keep offset addresses used in various forms of memory addressing. In the case of SP and BP, the default reference to form a physical address in the stack segment. The index registers SI and DI and the BX generally defaults to the data segment register DS. Stack pointer used with SS to access the stack segment. BP base pointer primarily used to access data on the stack can be used to access data in other segments. SI source index register. It is required for some string operations. When string operations are performed, the SI register points to memory locations in the data segment which is addressed by the DS register. Thus, SI is associated with the DS in string operations. DI destination index register. It is also recorded for some string operations. When string operations are performed, the DI register points to memory locations in the data segment which is addressed by the ES register. Thus, DI is associated with the ES in string operations. The SI and the DI registers may also be used to access the data. Flag register. The 8086 flag register is a 16-bit register used to indicate the current status of the processor and to control certain operations. It has two types of flags, status flags and control flags. Status flags indicate the result of arithmetic or logic operations. Control flags controls the processor's operation. Status flags. Carry flag indicates carry or borrow in arithmetic. Parity flag indicates parity of results. Auxiliary carry flag indicates for BCD operations. Zero flag shows if the result is zero. Sign flag shows sign of result. Overflow flag indicates signed overflow. Control flags. Trap flag. Single step mode. It is used for debugging purpose. IF. Interrupt flag. It is used to enable the interrupts. Set to allow maskable interrupts. Direction flag. For string operation directions we are using. And 0 for increment and 1 for decrement. Thank you.